plug in r, and we get r cubed over 2 minus r cubed over 3, and the zeros go to, plugging in 0 is 0, so you don't have anything else. Well, what is that thing? That's the question. Well, let's get a common denominator here, and we get 6 on the bottom, and so we get 3r cubed minus 2r. Well, yeah, 3r cubed minus 2r cubed, so that's just r cubed. And then 2 pi h over r. So is this thing, what is that equal to? Well, the r's, one of the r's cancels, so we get pi h r squared over 3. Pi r squared h over 3. So, that is what we were, trying to get at. See, because that's what I had said, that I thought the volume was, and it is. That proves it, using, the method of shells. It proves it. You don't, and it really isn't, it's a typical type of problem in calculus, though. I mean, you'll see these type of problems where you have to, set up an integral and calculate the volume of something that you're asked to calculate the volume of, and sometimes it's a lot more complicated than just a cone. But this is one way of, deriving. You always wondered in calculus, well, how does it work that the volume of a sphere is 4/3 pi r cubed, or what was it? 4/3 pi r squared h. 4/3 pi r cubed, or how is the volume of a cone pi r squared h divided by 3? Why is it 3? Well, the reason why it's 3 is because of all of this, because of the method, because of calculus. You see, and that's why it becomes the formula that it is because of integral calculus that proves it. And again, we could have used washers here, but it's really not a washer. It's a what would you call it? It is a washer, but it is I don't know what the word for it is. A degenerate washer, because the inside there is no inner radius, with this washer. It would have a 0 inner radius, which would actually make the problem simpler, even maybe, but it is a washer. But usually washers, have an inner radius as well as an outer radius, so that the washer ends up looking something like, this, and it actually has a thickness, like that, and but that's a different story. A washer is kind of like a penny with a hole drilled in the center of it, with a thickness, a finite small thickness. But that, will suffice for, I guess, a problem, with calculus, integral calculus at that, but, still, hope that this will help you to see, that I, have brushed up on my, skills, in calculus, so that I can help you, with your calculus, and that's what I'm, here for in my math tutoring services, to help you make it through calculus and explain things, to you and for your benefit. So I hope that you'll consider, scheduling a session with